So let's look at a couple examples of logs, and all we're going to focus on is how to say them. I have 4 examples. We don't need to write anything. All we're going to do is say them and identify its parts. If we look at this first one, what is this log's base? Its base is 10. What is its value? 100. That's on the inside. And what's its exponent? 2. The most important thing today is understanding what is on your page, because you have not seen these before. If we were to say this out loud, we would say log base 10 of 100 equals 2. Log base 10 of 100 equals 2. What does this mean? Logarithms are like a riddle. Logs are asking the question. So watch, this is the most important thing right now. We're going to learn to do these in the calculator, but you need to know what you're doing for the next steps this week. Here's what this log is saying. This left side is asking us a question. It is asking us the question, 10, that's the base, 10 to what power will give you 100? 10 to what power is 100? And look at what it's equal to. This is telling us that 10 to the power of 2 will give us 100. Logs are riddles. The base to what power gives us what's in our parentheses. So if we look at the second one, this is the example we just did in the beginning. 2, which is our base, to what power is 8? 3. The log found the exponent we need to raise the base to get it to the inside value. If you look at the next one, it's asking 4 to what power is 126? 4. If I raise 4 to the 4th power, I get 126. And finally, 3 to what power is 243? It's 5. Now, that's what a logarithm does. Now, when we're doing logarithms, it's not going to tell us what it's equal to, because that's the answer we're trying to find. Okay, but that is what a log does. It finds us the exponents that we don't know. And it's important to understand that in math, we've talked a lot about opposites operations this year. Many times this year have I not said, what's the opposite of adding? Subtraction. What's the opposite of multiplying? Dividing. Okay, remember, then I would ask you, the opposite of a square root is an exponent, right? Logarithms help us find those missing exponents that we don't know. That's its sole purpose in this world. They were created and discovered to find exponents that we don't know. Without them, we can't solve for an exponent. So, let's talk about the special types of logarithms. There are 2 special logs. They get special treatment. They're cooler than the rest. Not all logs are created equal. Every log has its own base. It can be anything. Okay? So, if you ever see a log base 10, this is a special log. This is called the common log. You know how like square roots we don't write the 2, or the 1 is invisible in a lot of math equations. The common log is the special log. It's so special that when you don't see a number written by log, you are going to automatically assume that it's a 10 right here. I don't see a base. Look, where is it? I don't see it. If there is no number written as a base, it's automatically the number 10, and it is called the common log, and it is right here on your calculator next to the 7. Do you see the log button? That is called the common log. That button is specifically log base 10. You can only use that button when the problem is log base 10. It's a special log. If you see a problem that's log base 2, that log is different on your calculator. The second special type is log base E. A log with a base of E. And remember, E is our special exponential constant. It's like the number 2.71 about. But if you ever see a log base E, you'll actually never see a log base E because it's called the natural log, and it's so special that it got its very own symbol, ln. Logarithm natural. I don't actually know why it's ln, do you? Where do we go with logarithm de natural? But ln is the natural log, and it has its own button too. It's right under log. See it? ln. If you see an ln, you have to use the ln button. You can't use log for ln or ln for log.
What does it stand for?
I don't know.
I just looked it up. It's the Latin name, logarithmus naturally.
See? I was right there. So literally, it's like logarithm, that's natural. Log natural. We just in English, these are adjectives before the noun, unlike most languages in this world. Okay? So, we kind of get the gist, right? Let's practice. Today is all about using our calculators to solve these. So we have many examples to get done. Here we are. See how many there are? Quick and easy. Okay, I'm going to pull them up. Now is the time where we should start writing down examples. I'm going to do a few with you, and you should be able to catch on from there. Do you want me to give you a second to write them all down first? Can we be speedy? Like, can we set the lawnmower to the rabbit mode? Not turtle? Rabbit. Don't you guys cut the lawn? Really? Your parents don't make you mow the lawn? My parents made me mow the lawn when I was like 12, and every Saturday since. Speedy. You don't need to leave a lot of room because we're just going to put them in the calculator. Log 1,000, log 0.001, log of 25, log of 50, log of 1 over 100, log of 9 halves, ln of 5, ln of 200, ln of e, ln of 1 half, ln of 0.75, and ln of 13 fifths. Now today is all about mastering evaluating, which means to put it in our calculator, we'll do it mentally. We can't really do logarithms mentally, but it's finding our answer. So log of 1,000. I'm just going to show you how to type it in the calculator, and it's not hard. Some of you I already saw doing it. If I look at my first one, if I look at my first one, is that a common or a natural log? Common log. So I'm going to use the common log button. Log. There's no base written, so it's automatically a 10. So I'm going to type in 1,000. And remember, what this log is, it's a riddle. It's saying 10 to what power is 1,000? You click enter and you should get 3, because 10 to the third power is 1,000. So my answer to that first logarithm is 3. We found the missing exponent. The exponent we did not know. Now, I'm going to skip around, okay? I'm going to go to the ln of 5. Okay? This is called a, what type of log? It's called an ln, but it's called the natural log. And natural logs have a base of e.
Which one?
ln of 5. Has a base of e. This is log base e, but it's so special we call it ln. So I'm going to use my ln button, which is right under the log button, the natural log of 5. This means e to what power is 5? Well, I definitely do not know, so I need to click enter, and I get a gross nasty decimal. Now, the rule of log is we are always going to write 3 numbers after the decimal. So 1.609. 1.609.
So do I do the same for the third one?
If it is a decimal, 3 decimal places for all of your logs. And I'm going to do one more with you, because I do not know if you remember where the button is, but this ln of e, this means e to what power is e? Well, let's find out. We click ln. The e is on the division symbol. It's a little blue e. So you click second, divide, and there's your e. Second, divide. There's your e. We click enter. Does that make sense? E to what power is still e? E to the first power. 1. If you have a fraction, you can just literally type in your parentheses like 1 divided by 100, parentheses, enter. Hey, you finish the rest of these logs quick, speedy. Type in your log. Evaluate your log.
So when you put in the parentheses, you put 1 divided by 100.
Oh, okay. So everybody knows who's right.
ln of 50, that looks... So, that isn't an ln, it's a common log.
Oh, right.
Yep, so you...
Oh, I didn't notice the LNs in there. Okay.
Yep. Be very careful. Some are log, some are ln. There's a difference. Question is, will do the change of dates? Yeah. Yeah. Show 'em both ways. Yeah. What do you do? Yeah, 5 divided by 2. Parenthesis, enter. Boom, got it.
Do I know who's that?
Yep, 3 decimal places.
Okay. I was just trying to make sure I'm doing it.
Yep. That's fine. You can get negative.
cheese.
You can check your answers as you're going. I'm writing them up. Okay, go ahead and check them. I got them here up on the board. Do not have them all down. That is A-OK. You just need enough examples to be able to go with that. You can come back here, or you can watch this video later to check them all and get them all written down. But I'm going to move on. Okay, write down your last one. I'm going to the next slide. It's okay if you don't have them all. I just put them. That's okay. You won't need them all. Okay. Next slide. So we know how to type in the common log, and we know how to type in the natural log. The issue is, sometimes we have logs with different bases. Here we have a couple examples where we have a log base 4, a log base 2, a log base 8, a log base 7. And remember, not all logs are created equal. I cannot just use this log button for these 4 problems. I can't just type in log of 1024, because that log has a base of 10. Remember, this right here means 4 to what power is 1024. Now, if you were old school, like me, I was not lucky enough to be able to type in a base other than common and natural in my calculator. I didn't get to. I had to do it the old school way, with a change of base formula. But I have provided you that change of base formula, which you could do, but you don't have to. I will show you the quick, easy way on our calculator, but you must watch and see the buttons I press. So watch carefully. If I am typing in this first one, log base 4 of 1024, I cannot use this log button, because that's log base 10. I need log base 4. I'm going to click Math and pull up my big menu. Here's my big menu. All the way at the bottom, I can just click the up arrow and I go down to the bottom. You will see log base. I'm going to select log base. And you can see I now have a log in my calculator where I get to choose any base I want. In this problem, I need a log base 4. So I'm going to plug in 4 for my log. And then I'm going to click the over arrow to get to where the value goes. And then I type in 1024. And I click enter.
Wait, how did you get that time before?
Math, go down to the bottom of your list. It is log base. And you can type in any base you want. So I get 5. I'll do another one with you. Log base 2 of 0.02. Again, math. Go to the bottom of my list. Find the log base. My base for my second problem is 2. And I'm going to type in 0.02. That's my value, and I click enter. And I get negative 5.644 if I round. Negative 5.644.
Who's doing the rest of these?
Yep. 6 more for you to do. Maybe good to write on your page somewhere that it's you get this log base in the math menu of your calculator. Logs find exponents. That's the most important thing you could learn today. They're finding the mystery exponents. What exponent gives us the inside number?
Okay, so I know I cannot have the 4, so we'll have to see what here.
Let's go. 0.138. 3 is smaller than 5.
Yes, I know, but I'm talking about. So I don't round this 3?
You only look at the last decimal point value that we want. So
So just the first 3 numbers?
Yep.
Wait, so
1.415 done.
wait a
One.
minute. So
Yes.
like, if
You only what? So we want 3 decimal places, right?
is
What's the third decimal place?
8,
You only look at the number before, like after the 8.
okay then.
Nothing in front of it changes. You got a log base inside of base. Look, I'll show you. Are you trying to change this 5 to something else? What do you want the 5 to be? Good. Very good. Good, good, good.
So 2.706.
What's after the 6? So that's going to make the 6A
Oh.
7. Alright, I'm going to start putting them up so you can check. Good, good, good. here are your logs that aren't common or natural. These are just other logs that can appear. Okay, so there's all 8s with the proper rounding. Remember, for rounding, you look at the third decimal place. You look at the number that comes after it. If it is larger than 5 or larger, you round it up. Anything under 5, and it rounds down. Questions on the bases? No? Okie dokie. We will learn how to rewrite them tomorrow, but for today I have the beginning of your practice. Do not leave this sheet, as your second practice that we will work on is on the back. Do we have a lot of time left? Not really, but you have enough time to do these problems. Evaluate, evaluate.